Good morning, grade 11. Hope you are all doing well. This is Miss Pamela Teeny giving the physics course. Today we are going to start with a new chapter, chapter 6, which talks about motion in 2 dimensions. Specifically, we are going to talk about projectile motion, which is section 1. So if you can all please open your books on page 152 so you can follow up with me. So what is a 2-dimensional projectile? During a baseball game with your friends, you throw a ball at an angle through the air. It takes a path through space as shown by the curved dashed line in the diagram below. The ball in this case is considered to be a 2-dimensional projectile since it's flying both vertically and horizontally through the air, and it's only under the influence of gravity because we ignore air resistance. So any object that is thrown through the air, either at an angle or horizontally, is called a projectile, and it has a projectile motion, which is a curved motion. And the only force that acts on it is gravity, of course when we ignore air resistance. We have 2 types of projectile motion. First, the motion of projectiles that are launched horizontally, as you can see in the figure in front of you in the upper part. This is a projectile that is launched horizontally with only an initial horizontal velocity. 2, the motion of projectiles that are launched at an angle. You can also see it in the figure in front of you, but in the lower part. This is the projectile that is launched at an angle, and it has both initial vertical and horizontal velocities. So they are both projectiles because they are thrown in air, and they have projectile motion because they follow a curved path, but the first one is launched horizontally and the second one is launched at an angle. Projectile's velocity. Since the gravitational force pulls downward, gravity will only affect the vertical component of the velocity Vy of the projectile. However, the horizontal component of the velocity Vx will remain unaffected, and it will stay constant as the projectile moves along its path. So since gravity acts downward and its effect is only on the vertical, it will affect the vertical component of the velocity. But the horizontal component of the velocity will remain the same. It will not be affected by gravity. It will remain the same as it was in the beginning of the projectile's motion. For horizontally launched projectiles, as you can see in the figure in front of you, at the beginning a horizontally launched projectile only has horizontal velocity because it is horizontally launched. So the horizontal velocity, which is Vx0, remains the same throughout the path of the projectile. As the projectile moves along its path, Vx remains the same, with the same magnitude. So the vector that represents Vx has the same length. However, concerning the vertical component, which is Vy, it increases as the projectile moves along its path. So it begins as 0 because this projectile is horizontally launched, so it doesn't have any vertical component of its velocity at the beginning, but it increases little by little until it reaches a maximum just before the projectile hits the ground. However, for projectiles launched at an angle, this is different because a projectile that is launched at an angle has both vertical component of its velocity and horizontal component of its velocity. As you can see in the figure in front of you, we have Vx0 and Vy0, which are the initial horizontal velocity and the initial vertical velocity. As the projectile moves along its path, the horizontal velocity remains the same. So the length of the vector remains the same and it doesn't change. But the vertical velocity decreases. Once the projectile reaches its maximum height, the vertical velocity is 0, and then it starts to increase again as the projectile is going down its path. Now comparing horizontal projectiles and objects in freefall. An object in freefall is an object that is dropped. As you can see in the figure in front of you, the first ball that is dropped downwards is an object in freefall. An object that has a horizontal projectile motion is an object that is thrown horizontally. As you can see in the figure in front of you, the ball that is colored red is a horizontal projectile. So first, they have several similarities. The first one is that the changes in vertical velocities are the same. So their vertical velocity is the same at each instant because it increases, it begins as 0 in both. So the initial vertical velocity is 0 and it increases according to the acceleration due to gravity. So the effect on their vertical velocities is the same. The average vertical velocities during each interval are the same, and both accelerate downward due to gravity at 9.8 meters per second squared. which is, of course, on Earth. So the acceleration due to gravity on Earth is 9.8 meters per second squared. So they both accelerate at the same rate because the only force acting on both of them is the gravity. Difference is that a projectile launched horizontally has initial horizontal velocity, unlike an object in freefall. So an object in freefall doesn't have an initial velocity, neither in the x direction nor in the y direction. But a horizontal projectile has an initial velocity only in the x direction. They both have initial zero vertical velocities, and their vertical velocities change in the same rate. They have the same acceleration downwards. Now we reach the part where we are going to talk about calculations in order to be able to solve problems in which there is projectile motion. Today we are only going to talk about the calculations for horizontally launched projectiles, and in the next session we are going to talk about angle-launched projectiles. 1. To find the horizontal distance that is traveled, we use the following equation. xf, which is the horizontal distance traveled in meters, is equal to Vx, which is the horizontal velocity that doesn't change. So if you have the initial horizontal velocity, you have Vx, times time, which is measured in seconds. So if you have it in other unit, you need to convert it to seconds, and then you put it in the equation. 2. To find the vertical distance that is traveled, which is Yf, also measured in meters because it is distance, it is equal to Yi, which is the initial vertical position, also measured in meters, plus half times Ay, which is the vertical acceleration, times time squared, which is measured in seconds. 3. To find the final horizontal velocity, which is Vxf, it is equal to Vxi. Since we already stated that the horizontal velocity doesn't change along the path of the projectile, and they are both measured in meters per second. So if I tell you that a projectile has an initial horizontal velocity of 20 meters per second, the final horizontal velocity will also be 20 meters per second because it is not affected by gravity, which only acts on in the vertical direction. 4. To find the final vertical velocity, which is Vyf, it is equal to Ay times t. Ay is the vertical acceleration measured in meters per second squared, and t is time measured in seconds. Finally, in order to find the time, we use the following equation. Time is equal to radical 2 times Yf minus Yi over Ay, where Yf is the final vertical position, Yi is the initial vertical position, and Ay is the vertical acceleration. Of course, time is measured in seconds. Some notes that you need to know in order to solve problems including projectile motion. 1. Always choose the coordinate system so that the positive x direction is in the direction of the horizontal velocity and the positive y direction is upwards, so downward direction is negative. If the initial vertical position is not given, then it is 0 meters. Ay and Yf, which are the vertical acceleration and the vertical final position, will be negative, and Ay is specifically equal to negative 9.8 meters per second squared. Why? Because they are downwards, and the downward direction is negative according to our coordinate system. Vyi, which is the initial vertical velocity, is 0 meters per second. This is why when we calculate Vyf, we use the equation Vyf equals Ay times t, not Vyi plus Ay times t, because Vyi is 0. And finally, the horizontal acceleration is 0 meters per second squared. Why? Because there is no acceleration in the horizontal direction. The horizontal velocity remains the same. Now, if you can all please open your books on page 155 so we can solve example problem 1 together. You are preparing breakfast and slide a plate on the countertop. Unfortunately, you slide it too fast and it flies off the end of the countertop. So this is a horizontal projectile. If the countertop is 1.05 meters above the floor and it leaves the top at 0.74 meters per second, how long does it take to fall and how far from the end of the counter does it land? So since they asked us how long does it take to fall, they need to know time. And how far from the end of the counter does it land, so they need to know the final horizontal position. First we write the given. The given, xi is equal to yi equal to 0 meters because we do not have initial vertical or horizontal positions. Ax, of course, is 0 meter per second squared because the acceleration in the horizontal direction is 0. Vxi, which is the initial horizontal velocity, is 0.75 meters per second as given. It is 0.74. I don't know why they wrote it 0.75. Then the initial vertical velocity is 0 meters per second because it is a horizontally launched projectile and not a projectile launched at an angle. The acceleration in the vertical direction is, of course, negative 9.8 meters per second squared. And the final vertical position, YF, is negative 1.05 meters. So it is negative because it is in the negative direction. First, we use the equation for time. T is equal to radical 2 into YF minus YI over AY. We put the values. T is equal to radical 2 into negative 1.05 minus 0 over negative 9.8, and the answer is 0.46 seconds. Then we use the equation for the final horizontal position in order to know how far did it travel. XF is equal to Vx times T. Vx is 0.74 and T is 0.46. So 0.74 times 0.46 equals 0.34 meters. So this is example problem 1, and it is an example of a horizontally launched projectile. Please, as a homework, solve numbers 1 plus 2 plus 3 on page 156. Your homeworks must be done and submitted to me on Tuesday, April 7. Thank you and good luck.